Welcome to CCC 2018. We're going to kick it off with a keynote here. My name is Jonathan Bachrach. I'm going to share the keynote with some of the organizers and steering committee of Chisel. I'm an adjunct professor at Berkeley, and I started and ran the Chisel project for many years. I'm now mostly an advisor and executive in the Chisel effort. I'm going to give you a little retrospective on how Chisel started and where we've been and all the phases. It's going to be about 10 minutes, very quick. So the backdrop is that at the time that we started, there was this, we recognized that chip design was very difficult, very slow, risky, and that there was an emerging need for more and more chips. There were more transistors available, but NRE costs were rising. So effectively, there was no version of Moore's law for NRE. At the same time, at Berkeley, we were doing a lot of computer architecture research and recognized that computer architecture research is very hard, and there were fewer papers with real chips and real results. And it was really hard to build real chips with real memory, et cetera, and extremely difficult to design and tape out chips. Again, at the same time, there was this trend in software, this agile development process, recognizing that the requirements would evolve during engagement with clients and that it was premature to design upfront like we were doing in hardware. So the idea was to apply good software ideas to hardware design and to make it possible to use small teams that were much more agile and to iterate a lot more times, to figure out what you want and be ready to tape out. So before this, just to go a little bit further back, I had also done a project at MIT and published this paper and had a little experience on applying this kind of software-oriented approach to hardware design, and the project was called GEL. Maybe not many people know about this, but this is a paper I published in 2008. So I came into Berkeley, and these were all the forces at work, and we came up with this project called Chisel. 2012, we had funding from Department of Energy, and there was a parallel computing lab that was funded by a number of big companies, including Intel and Microsoft. And so we coined this name Chisel for constructing hardware in Scala embedded language. It's really this idea of taking a modern language and embedding hardware foundations and primitives into it so that it was seamless, and so you could effectively take advantage of all the good features in programming languages. The other idea was to write software instead of doing high-level synthesis, instead just write programs that generate hardware called generators, and we were, since we were working with computer architecture group, that we had to do it in a way that would incur no inefficiency. We call this zero-cost abstractions. And we published the paper in 2012, and I just want to note that there's been just a ton of people that have participated in this project, and it was a real effort between the design side and the computer architecture side. And this, at the same time, there was this problem with trying to actually build chips, processors, because the instruction sets weren't readily available, and so the computer architecture group came up with RISC-V, which has skyrocketed in its uptake. So in any event, so what we did was we got together, we combined RISC-V with this idea of generators and came up with Rocket Chip. which is a generator for a processor family. Came up with this interconnect and taped out a bunch of chips and published a bunch of papers. At some point, we realized that things were getting, as all software does, got a little top-heavy, so we rewrote everything, and we kind of took a modern software stack approach to Chisel, and we also recognized how LLVM was doing really well for compilers and adopted that for Chisel, and came up with this thing called Fertile, Flexible IR for RTL. And the vision there was to create an entire ecosystem, not just locking into Chisel per se, but allow multiple front ends, multiple back ends, and then even write passes that target Fertile or transform Fertile. So we have a couple papers on that. And then we always had this idea that we would layer languages above Chisel, and so that opened up that possibility. And so this phase, we got funded by DARPA, and we did a lot of work on DSP because we were working with BWRC and a number of faculty and students over there. They did amazing work here, showing that you could layer up a domain-specific language, in this case targeting DSP. We'll hear about that talk today. Sort of a more recent phase is we got more funding and funding specifically from Intel and others at DARPA and we were being focused on figure a big bottleneck in chip design was simulation. We wanted to enable that to scale better, and now that we have this intermediate representation, we got a lot of leverage from that, and we could make simulation work a lot better. And just like in the recent past, a number of students graduated, and Krista, and they went and started a company called Sci5, you might have heard of, and they're productizing this kind of disruptive approach to doing hardware. And they've also been participating in Chisel development, and a number of my students have gone on to work there. And it's really exciting, and we're going to hear some talks from them today, and in intensive tomorrow. Okay, just want to recap a couple of the successes in the spirit of a retrospective here. One was that this idea of RTL in a language, in a programming language, and I would just say that I think it worked really well. The paper that we published actually has been cited 286 times, which is pretty good for a hardware paper. We taped out 17 chips. Here's the chips, and we were able to prove that we could, get a lot of velocity in hardware design, and we've been able to get a number of universities to adopt and companies working with us and using Chisel. One of the successes that really proved out this point of generators is the Berkeley out-of-order machine. At the time, it was pretty unheard of that you could write an out-of-order machine effectively in like 10,000 lines of code. The idea was that you could encapsulate the complexity of an out-of-order processor in a reusable fashion, where all the difficult and bug-prone elements could be captured in, actually functions that would be parameterized by very high-level concepts like data path elements and sizes, widths, and whatnot that were just unheard of in Verilog, and that really turned a lot of heads. And we're going to hear more about Boom. There's going to be an intensive on that tomorrow. And then agile hardware design really works. Like I said, we taped out a lot of chips, and I think one of the things I just wanted to note was in the craft program at the end of that, we were able to demonstrate a 10x speed up in design over traditional methods, which is really what we were hoping for, and so we were pretty excited about that. Definitely, we identified a lot of other bottlenecks that we had to attack, and that's been a lot of what we've been doing. and you're going to hear more about some of the more recent stuff that we've been looking at. So you have to really work on the entire design loop to get it to work and squash all the bottlenecks. But we're well on our way, and we're pretty excited about how agile hardware design works, and we're keeping working on that. And then I think the other thing is that was a big success was Fertile. So we weren't sure at the time, but LLVM worked really well for software compilers, and we were kind of more aggressive and radical about it. Really believed in this idea of an open compiler and even programming in this way where you basically write software to define the hardware elements as well as writing passes and actually targeting this intermediate representation. And we feel like we get a lot better reuse by doing that, and that's the focus of Adam's thesis. We really, it was kind of another level of pushing into this idea of a layered approach. And we really feel like we've gotten a number of wins. We opened up this entire ecosystem, and we don't think FPGA simulation would be tractable without it. And also it's enabling a whole new type of verification. Okay, I'm gonna turn it over to Schuyler here to talk about outreach.
So hey, my name is Schuyler Eldridge. I'm one of the Chisel and Fertile developers, primarily more on the Fertile side of things. That helps. So yeah, so I came to IBM Research by way of Boston University, so not with a specifically tight Berkeley connection, so to speak, but part of what I've been trying to work on is sort of to lead a new effort on outreach related to Chisel and Fertile and the whole Chisel-Fertile hardware compiler framework. And I think as you'll see this throughout all of the outreach slides, all of our GitHub things are shown here, which is probably where you know us better. So for outreach, what we're really trying to think about is sort of where we want to be with sort of the Chisel project in a year. So the good news is that there's a very active user community. We don't always know who all of the users are, but anecdotally it seems like user uptake is pretty big. And if you want to be a user and you just want to use Chisel or you just want to use Fertile, that's fantastic, keep doing that. But over the course of the next year, what we'd really like to do is to be able to convert some of those users who are really stakeholders in the project and they have some vision of where they want to take things, and to get those people involved in the development process. So the thing is right now is this was just scraped, this figure on the right was scraped from the last year of commits on Chisel and Fertile. Don't take this too literally because it sort of depends on whether your commits get merged or squashed, whatever. But primarily the developer community is pretty much centered around Berkeley, and we would really love to be able to diversify that amongst all of you in the coming year. So if we're able to get a bunch more slices up there, get this more into some kind of a 10 different slices, that would be fantastic. And if you're interested in getting involved in this process, please talk to me or talk to any of us. So another good thing with this is that we do actually have international developers. It's primarily centered in the United States, but there are a few people from China and India that have gotten code merged. So, but primarily we want to convert some of you guys who are primarily users, some of your developers, but to get you more involved with this process. So one of the things which always sort of comes up when I have to explain this is people ask me, you know, why is Chisel better than Verilog or VHDL or, you know, my favorite new hardware description language? So one of the things which is very difficult about this type of explanation is that you have to think about this whole hardware compiler framework that Jonathan was talking about. And what we're trying to do as part of outreach is sort of solidify this message and make it more concrete and more pithy so that you can help try and explain to other people, either if you're not convinced, to help convince you and help explain to you, but also you can help convince your colleagues and help convince your friends and explain to them what are the benefits of this whole process. So in a sense where the last slide was about trying to grow the developer community, this is really about trying to grow the user community. But one thing that's sort of critical here is that on the right is that it's, and as Jonathan mentioned, it's not so much just about the language, it's about trying to build a hardware compiler framework that you can, if you want to write a different front end, a different back end, if you want to write compiler passes, that's all something that you can do. It's tractable and it's easy. And on a bit of a lighter note, we've been trying to also increase sort of feedback and community interaction so that you have the ability to interact with other Chisel users, to interact with Chisel developers. And as related to this, we've revived the old Chisel HDL Twitter account as Chiselang and expect that to be much more active going forward. If you have user questions, reach out to some of the developers and users who hang out on the Free Chips Chisel 3 and Fertile Gitters, which is sort of, if you're not familiar with it, it's sort of like it's like an IRC channel associated with the Git project. Additionally, there's always the Stack Overflow Chisel tag. There is actually a rocket ship tag too and a RISC-V tag if you have things more specific to that. There's always the old Chisel users Google group, and as always, the best way to provide feedback on new features is through GitHub issues, pull requests, and either filing or commenting on requests for comments. So, but really what this all comes down to, and is I think what you'll see as a theme, is that we're very happy that, that you're users, but if you want to get more involved with the process, be more vocal, we'd love to have you. So that's it, and I'll hand it over to Richard for the development.
This does work. Hi everyone, I'm Richard, or Ducky, as you'll probably see more often on GitHub, and I'm a 6th-year PhD student at Berkeley, interested in usability and human factors in electronics design tools, and advised by Bjorn Hartman and Elad Elad. I am one of the core Chisel developers, and as you might expect from my research interests, I mainly work on languages and tools such as the Testers2 test stimulus package you'll hear about later today. And speaking of upcoming features, let's talk about roadmap. So one of our major focuses is the user experience in Chisel. We've heard the joke that is usability or human factors consideration in the modern EDA stack, and we think that better usability not only means happier engineers, but it could also mean more agile design in the form of less bugs and higher productivity. And to that end, we have a variety of features in the overarching category of quality of life planned. Some of these are new features like strong enums and tag unions, while others are overarching themes like improving language consistency and Verilog generation. We also know that getting engineers, or really anyone, to learn a new workflow or language is hard. And while we can't eliminate the learning curve completely, we have been trying to make it easier through the interactive Chisel bootcamp that you see right there. And anyone who's dabbled in any non-trivial hardware design understands that the real fun isn't in design, but it's in testing, verification, and debug. And there's plenty of work to be done there too. So we're working on improved visualizations to make understanding RTL behavior easier. This includes adding transaction-level semantics to the standard waveform viewer, visualizing the module hierarchy, and combining the two for an integrated debugging experience. And writing tests is also important too, and while there's agreement that unit testing is good, no one actually wants to write tests, so we're revamping the test infrastructure to make this lightweight and easy. And as we've seen larger designs in Chisel, performance has become more of an important issue, and sometimes running performance analysis reveals obvious problems with non-user-facing solutions, and we've implemented those when we can. And there are also times when we can get massive performance gains when the designer can give hints to the system, such as the proposed clone module API, which would basically allow you to get multiple instances of a module for free. Yet, the real power of Chisel isn't in its fundamental primitives, it's how those can be composed and reused. And much like in the software world, productivity in a language is also dependent on the libraries that exist, and when you can build on what someone else has done instead of reinventing the wheel. A major project here is Chisel DSP, which provides a standard set of both interconnects and digital signal processing blocks, which could be parameterized and dropped into some application circuit. We're also looking into expanding the standard library, going beyond from a few Q generators into a more comprehensive batteries included approach. And while Chisel provides a tried and true low-level RTL abstraction, other abstractions can be more productive for certain applications. There's research into building a UTL transaction layer or providing support for guarded atomic actions on top of Chisel. And on the verification side, there's also work into fuzzing to maximize test coverage, as well as system Verilog style assertions. And Chisel is just a part of a larger ecosystem of tools needed to build a chip. There's been some work on downstream tools as well that operate on Chisel output, including FPGA accelerated simulation tools like FireSim, or even synthesis in place and route. Finally, Chisel wouldn't be where it is without the contribution and feedback of all of its users. Get involved, build the designs in Chisel, give us feedback on core language features, or even contribute to the compiler and language. And next up is governance. So come right up.
Hi everyone, I'm here to talk a little bit about governance. My name is Jack Koenig. I am a former Berkeley graduate student, now current Sci-Fi software engineer, tasked with maintaining and improving Chisel and Fertile. And I'm one of the lead developers on both of the projects, so I really have to touch the whole stack there quite a bit. And so I'm talking a little bit about governance because, well, first of all, people have asked us about this many times. And the basic motivation is that Chisel and Fertile need to graduate. Their use and needs have expanded far beyond what a group of graduate students at Berkeley can really afford to do with their time. That's why like at Sci-Fi we are hiring people to do this, but in general we're really trying to build a bigger community, and to build a bigger community you need to have formal structures in place to support that community. So the basic idea here is that we need some organization to drive the vision, to provide stability, to do outreach, organize conferences like this one, secure funding where necessary for conferences, for compute resources, for continuous integration, things like that, and to resolve disputes which inevitably come up when any project reaches a large enough size. So a big part of governance in any project is what does it mean to be a member. So, at the top we have a board, which is kind of like the overseers of everything in order to just make sure everything goes according to plan. I put a star there because we are looking to join a larger parent organization, but for now, until we have that, we have a board of Jonathan Bachrach, Kirsta, and Yunsup, who are have been very involved in this project since the beginning. So we have administrators who are the people who are kind of like the day-to-day management of a given project. They lead like a specific project like Chisel or Fertile or the testers. They set goals, they create working groups to say add features like asynchronous reset, and to whenever disputes come up between different contributors to resolve those disputes. So generally the board is just kind of like there in case it really needs to be there, and also to approve new project administrators, but really the people who run each project are the admins. So then we have reviewers who basically are people with right access to a given repository, and they're the primary drivers of development. We have developers who are people who are regular contributors who agree to 5 hours a month, and we're looking for feedback on this, but we're trying to have some requirement in order to make it possible to give people a vote. So developers have voting rights, and so in exchange for those voting rights, they're expected to do some amount of contribution. I should point out that contribution doesn't just mean writing code. It means creating pull requests, reviewing pull requests, submitting issues, discussing issues, answering questions on Stack Overflow, attending meetings, writing blogs, writing documentation, and also, importantly, providing feedback on releases. So whenever we have an upcoming release, we would like users to run it on their internal code bases and let us know if it works or doesn't work. And then, of course, anybody who contributes at all is a member of the project. So we are calling them volunteers, but that's just anyone who may not be willing to dedicate a set amount of time, but does contribute however much they can. The basic organization that we have is, we have CLA, which we're currently still trying to get onto the repository, but we talked about this at length and we decided on a pretty lightweight CLA, so there's no assignment of copyright. Instead, it's just a positive assertion that you accept the contribution under the license. You can debate if that's necessary. You can read about this online. People have debated about this for man-years. And anyway, we thought that that was a nice compromise. So we have a constitution proposed. We have reviewer guidelines and contributor guidelines. And you can find all these documents that I just mentioned on the Free Chips Project Chisel and Government's repository. One of them is merged and the other two are PR'd, so please take a look, provide feedback on what you think about those. We have our initial board, administrators, and reviewers created from past involvement. But really we're seeking community involvement and feedback on how you think this project should be governed, and we're looking for a parent organization ultimately to kind of be the umbrella over the whole thing. And that's it for me. Next up is Adam.
Okay, so I'm going to give just an overview of what the conference is, and so my name is Adam Izraelevitz. I am a sixth year PhD student, and my sort of thesis is Fertile and related work, and I'm currently an administrator and developer of Fertile. So my GitHub is Azadar, so you'll see me around. The main reason we wanted to have this conference was to build the Chisel community. We knew we had a lot of users and people a lot interested, and we really wanted to just enable people to network, get to know each other, and maybe build something together. We also, there was a sense that we needed to get this project out of Berkeley, and that means communicating better with people not sitting across from us. So, establishing this governance and communicating large decisions with the community was really important. We also want to increase adoption, and that means new and exciting features. It means more documentation. It means better, more regular releases, and higher standards of development and contributions. Finally, it's hard to learn Chisel, and we understand that, so we need to promote Chisel education, and this can mean providing documentation and resources to professors, as well as just educating the community on new and exciting things. So we hope that as these conferences continue, we can keep working towards these goals. The overview of the conference is as follows. Today will be 4 talk sessions, each one with a different theme. The first is architecture, and then productivity, tools, and then verification. And there will be 30-minute breaks, large breaks between them, because the biggest thing is everyone is here in person, so get to know each other. Who's in the Chisel community? So I want to meet a lot of people today. After the talks, we will be having the lightning poster previews, a poster session, and lubricated discussions. Finally, tomorrow, we have sort of a different format. We have 3 parallel tracks, one on beginners, one on architecture, and one on for developers, of what we call intensives, which are basically a 1 hour, 15-minute discussion led by a project leader and seated with the prepared slides. And the biggest thing is we're all here in person, sort of, if it's possible to ask all of your questions, get all of your questions answered by the people who are most familiar with the project, let's enable that. We have the ability to screen capture the intensives and record the audio of the room. Whether we actually do this is going to depend on each intensive and what the audience feels is most appropriate. We prioritize the people here over the recording. So if you feel that it won't, you don't want to speak because you're being recorded, and we feel like that would limit discussion, then we won't record, okay? If you feel strongly that it'd be great to be out there for the community who couldn't attend, we can also do that, okay? So we're gonna leave it at the discretion of the audience and the intensive runner. After all of the intensives, we will be doing a birds of a feather discussion. Basically, it means unstructured discussions around different topics. And that will be everything. There is a pre-conference survey I believe everyone got. I also believe the link is broken, so I will fix that. But please fill that out if you can. It helps us pick which rooms, because we have different size rooms for which intensives tomorrow, so that's useful. Finally, I wanted a big thank you for everyone's effort in both attending and in organizing. So thank you to the program committee. Thank you to the conference organizers. And thank you to the Adept staff who really went above and beyond in making sure that this event happens and will run smoothly. So I just give thanks for everyone who contributed. And finally, there's one more announcement, which is I'm excited about. There's going to be another CCC event in 2019 in China. It's going to be in Shanghai in a weekend sometime in between March and May of 2019. And we're still figuring out the exact details, but you can mark that general large location in your calendar. We have some industry sponsors, but we're looking for more. And stay tuned. Subscribe to the Chisel Announce, which is where we're going to be announcing updates about this. There will also be a Bay Area CCC around this time next year. So if you can't go to China, you can still come to this one. Okay, and please email me if you're interested in helping organize or contributing in any way to the Chisel. With that, thank you, and let's start the conference.